this video, we are going to solve the system of three linear equations with three variables. And if you can see right now, right in front of you, there is a system with three linear equations, 1, 2, and 3. And there are three variables x, y, and z. It looks unusual because so far we were dealing with system of two linear equations with two variables. But if I'm going to ask you, do you know how to solve this system? I'm sure that you're going to say yes, because this particular one is very friendly. If you can look at the third equation, you will see that this equation is already solved for variable z. Z equals 3. So somebody did the job for us and told us, okay, z equals 3. Very good. Now, we are going to use z equals 3 and plug it in this 3 into the second equation. And after we do it, we will be able to solve for y. So we are going to use the second equation, 2y plus z, but instead of z, we are going to use 3 equals 1. And when you solve it, when you subtract 3 from both sides, you will have 2y equals negative 2, or y equals negative 1. So now we know two variables of this equation. And we are going to use the first equation, 2x plus 3y plus 2z equals 13, and plug it in instead of z 3, instead of y negative 1, and solve for x. Let's do it. 2x plus 3 times y, which is negative 1, and plus 2 times z, which is 3, equals 13. When you solve it, you are going to have 2x, let's combine like terms, negative 3 plus 6, which is plus 3, equals 13. If we subtract 3 from both sides, we will have 2x equals 10, or x equals 5. In this case, we have now we have the answer for this particular system of equation. And answer is order triple with x equals 5, y equals negative 1, and z equals 3. Of course, we can check the answers. However, if somebody is going to ask you, can you please look at this system of three equations with three variables and try to solve it? And this one definitely doesn't look friendly. This is complicated, and in the next video I will show you the algebraic solution of this particular system. But let's talk about what those are. Because so far in a system of two equations with two variables, we know that graphically it represents two lines that are either intersect in one point, or they're parallel, so the system has no solution, or they coincide and therefore the system has infinitely many solutions. Those equations here are not lines, they're planes. And let's have a look at how it looks like. On the very first picture, you can see three planes, red one, green one, and purple one. You don't have to be worried about how the equation looks like, just look what their solution are. And the solution is a place where they intersect all together, and it's one single point. And in this case, the system has a solution which is triple pair, order triple. In the next picture, you will see that three planes, they intersect, but the intersection not a single point. It's actually the set of many, many points. It's a line. And since line contains infinitely many points, we say that in this case, the system has infinitely many solutions. On these two pictures, the solution of these two systems is actually doesn't exist. There is no solution because these three planes, they do not intersect at all. If they do not intersect, they have no solutions. In this picture, planes do intersect, but they don't have anything in common. So, for example, this plane, they intersect in this line. This plane and this plane, they intersect in this line. But all three together, they don't have anything in common. And this system also has no solution. In the next video, you're going to see how to solve the system of three linear equations with three variables algebraically.